Okay, my original plan was to power this up before taking apart the CPU, but I really do want to get a look at the DB25 connector, what it's hooked up to inside of there, so I think I might actually tear into this CPU unit right now and see what's inside of it. Put the back off. As before, we've got a fan connected via a 3-pin connector. Reset button hidden up there. Bit of dust in there. The fan is smaller than the fan was in the hard drive unit, and that little gray box is not here. Shield just pulls off. Oh, look at that, we've got our card cage, nice and accessible. The power switch. And the power switch is way down here. And there's a lever that moves the power switch up and down, so we'll have to make sure we get that lined up properly when we put it back together. Some kind of little sticker in there. It's fallen off. There's a snap rivet here holding the DC-DC converters in. So if I want to get my I/O board out, there we go. One I/O board extracted from the rest. There is our I/O board. There are a few ICs here under this shield. Got some metric nut drivers. Maybe one of them will be close enough. Not that one. Yeah, that one will work. And they also heat sinked some kind of regulator or transistor or something onto there. It's an LM317 regulator. It's kind of stuck on there. There we go. See, it does have an insulator pad. So now we can get a good look in here and we can see where those lines terminate. So it looks like a bunch of them went into this resistor. This is a 330 ohm resistor, and then from the resistor they're breaking out to these two ICs. So what we could do is we could map these pins to these chips and we can get an idea of what is going on there. The other pins from these two are going down here to the edge card connector, so I suspect these are buffering those lines. Okay, I spent a lot of time with the I/O board using a continuity tester and this breakout board here to check the pins on the connector and see where they go on the board to try to figure out what they all do. So let's see what all we have. Okay, so here is the breakout board and the pinout according to the breakout board. It went 1 through 13 here and then 14 through 25 there. If you look at an actual DB connector, I think that might be reversed on one of them. It might be 14 to 25 there. But the pin numbers are correct regardless. So I went through each of these and tried to figure out what they did. The ones marked EC came out to the edge connector that goes to the motherboard on the I/O board. So there's 1, 2, 3, 4, 5, 6 of them pins from the DB25 that went straight down to the edge connector into the motherboard, and presumably those will come back up into the video board someplace. We'll have to figure out what they are. There's also a bunch of grounds. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grounds on this DB25. That's not completely surprising. Some of them may be current returns for something that's being powered. Others may be signal returns for the various signals. People on video will often have extra grounds so that you can use shielded cables for the video, or you could use twisted pair or something. So it's not surprising that there's a whole bunch of ground pins. It's kind of expected. So these 4 pins here marked 74S240N, 2 here and 2 here. They go to an IC on the I/O board that I think is a buffer. I think these are digital I/Os. They do go through a resistor on each one. Maybe the resistor's there for protection in case something gets shorted. And my guess is that these are for the keyboard. And the reason I think so is that the keyboard, looking at similar keyboards made by Convergent Technologies, does have a data in, a data out, and a reset. So that would account for 3 of these, you know, an in and out and another out for the reset. That leaves a 4th output. I'm guessing maybe this could be speaker. It's possible. I'm not sure. So next up, let's talk about power that's coming out. So there's 3 pins here marked plus V. There's 12, 13, and 25. All 3 of those pins are connected, and all 3 of them go to the middle pin of a LM317 adjustable voltage regulator. So that's some kind of power that is coming out on that connector to power either the monitor or the keyboard or something. It doesn't seem like you could power a monitor with a 1.5 amp regulator, but who knows. The power going into that LM317 is the 36 volts from the power brick. So this could be, you know, this could be 30 volts. It could be 24 volts. We won't know till we find out. Now the other thing that's interesting is this enable pin. This pin 23, it went to this, I traced this all over the board. There's a dual transistor circuit. I'm not sure I have the collectors and emitters marked right. So the signal comes in on pin 23 on the connector. There's a 10K pull-up. Then it goes through a 1K resistor, which is driving a transistor. That transistor is being used to pull down the base to another transistor. And that transistor is being used to ground the adjust pin on the LM317. So this pin 23, I'm almost certain, is an enable pin for that LM317 voltage regulator. If you ground pin 23, then whatever voltage that LM317 produces is going to come out on pins 12, 13, and 25. So that must be used to shut off that voltage regulator when nothing is connected. So the next step is to figure out what these edge card pins do. My suspicion, given that this is the monitor connector and nothing else looks like video on this, would be that these 6 pins end up going through the back plane into the video board, and that they are some kind of video outputs. Now we would expect there to be a horizontal and vertical sync, a video, and an intensity, but we actually have 6 pins. So here's the video board. I did spend some time trying to trace the pins from the I/O board onto the video board, but I only found 2 of them. There were a total of 4 pins that did actually show up on the connector, but 2 of them appeared to not go anywhere. 2 of them I did trace to some ICs. We can try to figure out what they're for. And the other 2 of them didn't break out to the connector at all. So I didn't have a whole lot of luck matching those signals up from the I/O board to the video board. That's the front of the video board. Here's the back of the video board. So we'll just have to try it with the oscilloscope and see where we get. So I'm just going to do a top-down view. I'm not going to take out these 2 inside boards, just so people can see what this thing looks like from the top. So we had the I/O board here, we've got the memory board there, we've got the CPU board, and then we've got the video board. Another view. This angle. Here's a shot of it from that angle. Oops. And then in the back, of course, we've got the two DC-DC converters. So that's about as far as I'm going to get with this. I think I'm going to put it back together now. So here's the keyboard. This foil shield covers up a bunch of the ICs. We've got two SDL jacks, one on each side. That's just so that you can choose left or right-handedness. You can have the cable come out whichever side you want. We have an F8051 microcontroller is the smarts for this. So I spent some time trying to figure out what pins go where. I found out that pins 1, 6, and 8 on the SDL connector are ground. Pins 3 and 4 are 5 volt. Pin 2 goes to 74132. That's this guy here. He hooks up to pin 13 on there, which goes in through a couple more gates. It ends up going over to a 74LS00 that's over here, which ends up going into pin 15 on the microcontroller. I believe that is an input. That's probably data into the keyboard. Pin 5 goes over to the 74132, pin 5 on it. That is a gate. That gate comes out on pin 6 here, which goes to pin 9 on the 8051, which is reset. So I'm saying pin 5 is probably reset. Then pin 7 goes over to a 7416. I think that's this here. And that is actually an output. This is like a hex inverter. And that goes over to pin 4 on the microcontroller. So that would be the data out from the key. So we've got pins 1, 6, and 8 are ground. 3 and 4 are the 5 volt. Pin 2 is data in. Pin 5 is reset. And pin 7 is data out. I'm reasonably confident that's correct. So I did get a power supply for the Convergent Technologies computer. Here it is. I've opened it up so we can look at it. I've already removed this this big shield that was over the top so we can get a look at the insides. On the end, we have one of the SDL8 connectors, just like the keyboard, just like the computer, keyed appropriately so it does plug into the computer. Very beefy construction. It's got these huge heat sinks that run down each side. There's lots of TO220 type devices mounted to these heat sinks. Some of them are 2-pin devices that I think are diodes with a D symbol. Other ones are probably MOSFETs or transistors or whatever you used back then. Some ginormous capacitors. These are 200 volt, 440 microfarad, 4 of them. Transformers here, here, and here. This thing is produced by who is it? Aztec. Just like the DC-DC converters that are inside of it. It's interesting, there's what looks like a switch here, maybe like a 220-120 switch, but it's covered over, so you can't, if there is a switch there, you can't flip it. It has the standard PC connectors on the back. Just not a whole lot surprising here, very much what you'd expect, though super, super beefy for the time. But again, that's not a big surprise here. A lot of what you'd expect to see in a power supply. Pretty beefy and clunky for the time. You know, nowadays we make things much smaller than this. And if you're going to restore this computer, you'd almost consider why not just toss this power supply and get yourself a Meanwell or something that would weigh a fourth as much and probably be twice as efficient. Anyway, I'm going to put this back together and we can try it out.
Oh, hard! Be careful, it's hard! Be careful.
Something bad happened to the power supply.
Why?
I don't know, Leia.
You just electrocute yourself?
Why?
No.
Why did so?
Okay, so it turns out that all of my hard work going through the I.O. board and trying to trace the signals was somewhat in vain because I actually got it somewhat wrong. And I have the answer right here. 3 of these pins that I thought were going to be for the keyboard are for vertical sync, horizontal sync, and video output. And those are the 74LS240N gate on the I.O. board. Furthermore, I actually marked this one down as an input when it's actually an output. I probably got the pin number wrong when I was tracing it. But anyway, I will update this on the website. So I'm going to show just how simple it was to figure this out. You can see the breakout board here coming off of the video connector on the I/O board. Ignore these blue and black wires, we'll get to those in a moment. We've got my trusty oscilloscope hooked up, and if we go over here to pin 17, we see something's going on there. And what that something is a signal at approximately 22 kilohertz. That's consistent with horizontal sync. Now if we go over here to pin 18, you'll see there's another signal. This one is at approximately 60 hertz, and that would be consistent with a vertical sync. Now if we go over here to pin 7, we see some bursts showing up on there, and those bursts are the video signals. So it was really as simple as that to figure out 3 of the video pins. Now there's a 4th one someplace that's going to be intensity, but until I have something on screen that I know actually has intensity and it's not just all the same intensity level, it's going to be hard to figure out which one of these pins is intensity. Now, given that we figured that out, I have a gizmo here that we're going to use to try to get video. This here is my NGEN. There's plans for these on the internet. I downloaded the PC board schematic and I downloaded the Verilog code and everything, and I built this thing. I've used this previously getting an IBM PC with monochrome to work, and I've decided to use it also with this project so we can take our monochrome video and output VGA. Now I did have to make a few programming tweaks to this to get it to work with the Convergent, because the Convergent is using a bit clock that is 19.98 megahertz. That's different than the one used in an IBM PC. Its monochrome refresh frequency is 60 instead of 50. Its horizontal refresh frequency is different, etc. But anyway, let's plug this in. Let's pan up to my monitor. And here we have video on my VGA monitor coming from the Convergent. So you can see some things are a little bit weird. I don't know why this M is flickering, or this asterisk is flickering. Maybe that's actually the intensity signal at work. We'll have to probe around and see. But you can see, I think these asterisks had to do with the memory tested boot. The EA2 is probably an error, probably due to the missing floppy hard drive storage unit, which I don't have plugged in. And then this down here is the boot prompt, which is probably prompting you for how you want to boot this. So anyway, I feel like we've really had some good success here. We are actually getting video out of the computer onto the screen. This was like the hardest assumed part of this was going to be to decode this DB25 and figure out what it means. We've got that. We've proven the MCE2 VGA actually works on it. And as soon as we get the keyboard hooked up, we will be able to operate this PC. Okay, as you can see here, I've had some success getting the keyboard to work. That's me hitting the return key. Now what I did is I looked online, and on BitSavers I found a board called the MA01. That's this thing here. I printed out a picture of it. You can find it on BitSavers in the Convergent NGEN pictures directory. And I'm not sure exactly what this is. It appears to have the DB25, the keyboard connector, and a 15-pin high-density VGA connector. So my best guess is that this board was for a VGA variant of the Convergent computers. There are a few VGA ones. They're newer. It's not this one I own. So what I did is I traced the lines, and there's pictures of both sides of the board, so I managed to trace the traces going from the keyboard to the DB25. And I found that we had pin 22 was output to the keyboard, pin 21 was input from the keyboard, and pin 14 was reset. Now I'll be putting all this up on the website in a more easily documented form. So I also had my pinout of the connectors, so I also put that on the website. So I just took and I cut off the end of a keyboard cable. I kind of hated to do that, but it was the easiest way to get a good connector, and wired ground and the reset in and out to my DB25 board, and then lo and behold, we have the keyboard. It's a little bit wonky because you push some of these things that are not letters on this bootloader, like the caps lock key is printing an E. Let me see what a B does. If I do a B, okay, B actually did print a B, and now I believe it's probably trying to boot. And I don't think there's any way to abort it from here other than to wait another 10 minutes for it to time out. So I'll wait for it to error out because I still don't have the floppy hard drive module connected. And then in like 10 minutes, once it's errored out, we'll resume this and see if we can hit some of the other keys and see if it does anything. But the good news is we have both video and keyboard. We're able to talk to the computer. That's a pretty good degree of success, I think. Okay, it took about 10 minutes for the boot attempt to time out. Let's try another button. Let's see what the D key does. It just says D. And then an EA2. Let's see what happens if we push L. L. Bet you we're going to get another EA2 out of that. I mean, it looks kind of like the symbol it printed when it was trying to boot. So, presumably, another 10 minutes it will have timed out from this and we can try the other key. Okay, 10 minutes later, let's hit the next button and see what happens. This will be the M. Maybe that's a memory test. I bet that's a memory test. It's printing out asterisks. How many asterisks? 1, 2, 3, 4, 5, 6, 7, 8. 8 asterisks per row. So it just sat there printing asterisks for about an hour before I eventually rebooted it. I think it was just running memory tests over and over and over again. So rebooted it and we'll try the next option. Now, in the middle of that sea of asterisks that lasted an hour, there was one missing asterisk and a few screen flickers. So I don't know if that is a bad sign, and if that maybe means there is some questionable DRAM someplace in here. But anyway, let's try the P command. Oh, that looks like an address. It's weird that the shift key, yeah, the shift keys don't work. I want to hit like a question mark, and what does H do? Yeah, it doesn't understand that. Assuming this is a memory debugger. And D for dump, maybe? Yeah, I don't know. A, B, G for go. Q for quit. Yeah, I don't know what this does. Be happy just to get back out of it. Yeah, so P exits it. Yeah, so that was P. It seemed like some kind of a debugger. Let's try T. OS. I don't know. Yep, I think we're going to need a manual to know what the bootloader does. Anyhow, I think this is where we're going to conclude this part of the series. The next video, we're going to actually install an operating system on this. So you'll notice I do not have hard drive, floppy drive module there because I wanted to concentrate on just getting video and keyboard working. Certainly we've got video and keyboard working. Next time we will plug in the storage system, the hard drive, floppy drive. Maybe we'll try to boot off the floppy. Maybe we'll try to boot off the hard drive. I do want to try to make an image backup of the hard drive before we do anything that might damage it. So it may take a little brief pause to do some imaging of the hard drive. But this has given me confidence that we can get this computer going. So I don't know how clear this screen has been to everyone. My apologies if it's like nasty and hard to read because I am videoing an LCD monitor. Next time, if we actually dive into running some software on this, I will probably take the time to install a VGA capture device and capture video directly off of the MC to VGA so that we won't have any camera artifacts of, camera taking a picture of an LCD monitor, that sort of thing. Anyhow, I hope you've enjoyed, and stay tuned for the next episode where we will get some software running on this thing. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.